I want you to forget about the next hot app for a second. Forget about a slightly faster computer chip. Because what's happening right now, it's a physical transformation. And the scale is just, it's almost hard to wrap your head around. Yeah, this isn't about software. We're talking about pouring concrete, laying down miles and miles of fiber optic cable, all at a speed that is just breathtaking. In fact, some are calling it, and hey, don't take my word for it. That's a direct quote from Jensen Huang, the CEO of Nvidia, the company at the absolute epicenter of this whole thing. So what is being built? And why on earth is everyone comparing it to the first industrial revolution?
Well, it's because this isn't just a software update. The AI boom is a revolution of atoms, not just bits. It demands these colossal new factories, a totally new kind of fuel, and really an entirely new physical architecture for the planet.
Think about it. It feels so simple, right? You type in a prompt and poof, a perfect poem about your dog just appears out of thin air. But behind that little bit of magic, oh man, there is a chain reaction of just immense physical and energetic cost. And this is the scale of that cost. By 2030, AI data centers are on track to use as much electricity as the entire country of Japan. No, that's not a typo. We're talking about the power bill for the world's fourth largest economy, just so we can ask an AI to write poems about our dogs. This kind of demand is forcing a complete bottom-up rethink of how we power our world. Any industrial revolution really needs two key things: a new kind of machine and a whole lot of money to build it. So let's follow the money. Okay, get this, $400 billion in a single year. We're not talking about a few venture capitalists sprinkling some cash around. This is more than the entire Apollo program, adjusted for inflation, being spent every single year to build the foundation for this new age. It's just staggering. So who's writing these massive checks? Well, it's a really short list. We're talking about the hyperscalers. You've got AWS, laser-focused on global reach. Microsoft is all in on its Azure AI platform. Google's playing the long game, leveraging its deep vertical integration. And Meta, they're building this gigantic internal infrastructure just to train their own models. These guys, they're the new industrialists. And this chart, it really puts it all into perspective. This is not a friendly competition. It's a flat-out financial arms race. The companies that are spending the most and the fastest are positioning themselves to own the means of production for intelligence itself. Think about that.
All right, so where is all this cash actually going? Well, it's going into the machines. The data centers being built right now, they're not just warehouses for servers anymore. Think of them as purpose-built factories designed to produce intelligence.
And inside every single one of these AI factories, you're gonna find the same engine, the GPU. Now, what's just mind-boggling here is the sheer dominance. We're looking at a 92% market share for Nvidia. They're not just a supplier. For all intents and purposes, they are the sole provider of the engines powering this entire revolution.
But here's the catch. Getting your hands on those GPUs is unbelievably complex. This whole revolution, it hinges on this incredibly fragile and super constrained supply chain. It's not just about designing a cool chip. You need the most advanced fabrication on Earth, a special kind of memory called HBM, and this wild packaging process called CoWoS. A bottleneck in any single one of these steps can grind the entire thing to a screeching halt. And believe me, these bottlenecks are very, very real. Take high bandwidth memory. It's basically the lifeblood for these GPUs. It is completely sold out for years to come. This isn't just a temporary supply crunch. It's a hard structural limit how fast this new world can even be built. So this massive bottleneck has forced a huge strategic split. Most companies, well, they just have to get in line and wait for their Nvidia GPUs. But Google, they took a totally different path. They designed their own custom chips, their TPUs. And this gives them this incredible advantage in cost and efficiency, and this is the big one, in supply. They're not waiting in line. They basically own the whole factory. Okay, so let's recap. You've got the money, you've got the factories, you've got the machines. But none of it works unless you can plug it in. And that, my friends, brings us to the most critical and frankly, the most shocking part of this whole story, the hunt for power. See, these AI factories, they are thirsty. They need constant, 24/7, rock-solid baseload power, the kind of power that wind and solar on their own just can't provide. So what's the solution? Big tech is making a massive pivot to the one carbon-free source that can deliver: nuclear. And just look at this timeline. These aren't some vague promises for the future. We're talking about concrete deals to restart old plants and build new ones, and it's all happening right now.
And what's fascinating is they aren't all making the same bet. Microsoft is all about speed, right? They're restarting the infamous 3 Mile Island plant. Amazon is betting on massive scale, planning whole fleets of these new, small modular reactors. And then there's Google. In classic Google fashion, they're betting on pure innovation, funding wild experimental reactor tech. These are incredibly high-stakes gambles, and they really reflect the core DNA of each company.
And this is why that dramatic pivot is so absolutely necessary. A single ChatGPT query, it burns about 10 times more energy than a regular old Google search. Now, take that difference and multiply it by billions of users and trillions of queries. That's it. That's exactly why these tech giants are suddenly in the business of buying nuclear power plants.
So, let's pull it all together. What does this all add up to? You've got this unprecedented fire hose of capital. You have a brand new kind of factory. You have a super fragile supply chain for the machines. And you have this desperate hunt for nuclear power. When you put all those pieces on the board, what you're seeing is a completely new architecture of industrial control.
And the result of all that is what we're calling the AI factory. And I really want to stress, this is not just a data center. It's a fully vertically integrated system where every single component, I'm talking from the liquid cooling pumps all the way down to the fiber optic cables, is designed for one purpose and one purpose only: to manufacture intelligence at a massive scale. And this right here, this is the blueprint for the ultimate endgame. Just look at Google as a case study. They own the custom chip, the TPU. They own the data centers 100%. They're securing their own nuclear power deals. And they own the software that orchestrates the entire symphony. That level of vertical integration, it creates a competitive moat that is, well, it's almost impossible for anyone else to cross.
So we have to end with this question. Back in the first industrial revolution, owning the factories, owning the railways, that created empires of unbelievable wealth and power. So today, as we watch this new infrastructure for artificial intelligence get built, we have to ask ourselves, who's building it? And what does it really mean when just a handful of companies own the literal means of producing intelligence itself?